Title: Water Harvesting, Conservation, and Recharging: Sustainable Solutions for a Thirsty World segment. 1. Understanding water scarcity. Water scarcity is a pressing global issue that affects millions of people and ecosystems. It is crucial for us to take action and find sustainable ways to conserve and recharge our water resources. Segment 2. Water Harvesting Techniques. Water harvesting involves collecting and storing rainwater, runoff, and other water sources for future use. Popular techniques include rainwater harvesting, greywater recycling, and stormwater management. Segment 3. Benefits of water harvesting. Water harvesting offers several benefits, such as reducing reliance on traditional water sources, relieving pressure on water systems, and conserving precious resources. Proper stormwater management also helps prevent flooding and soil erosion. Segment 4. Water conservation practices. Water conservation plays a crucial role in sustainable water management. Implementing efficient irrigation techniques, using water-saving fixtures, and adopting behavioral changes can make a significant impact. Segment 5. Groundwater recharge. Replenishing groundwater levels is vital in regions with depleted aquifers. Methods like infiltration basins, recharge wells, and percolation ponds facilitate groundwater recharge, ensuring its long-term sustainability. Segment 6. Success stories and challenges. Real-life success stories inspire us to embrace water harvesting, conservation, and recharge practices. Communities and individuals who have made a positive impact demonstrate the effectiveness of these approaches. We also address common challenges and provide tips to overcome them. Segment 7. Call to action and conclusion. Water is a precious resource, and it is our responsibility to protect and preserve it. By incorporating water harvesting, conservation, and recharge practices into our lives, we can make a significant difference. Together, let's create a sustainable future for all. Outro. Remember, our actions matter in shaping a water-secure world. Let's continue to learn, adapt, and make positive contributions. Stay informed about environmentally friendly practices by subscribing to our channel. Join us in the journey towards water sustainability. Title: Types of Various Drives and Their Applications: Powering Innovation. Introduction. Welcome to our YouTube video on the types of various drives and their applications. Drive systems are essential components that enable the power and motion transmission in machinery and automation. In this video, we will explore different drive types and their diverse applications across industries. Let's dive in. Types of drives: mechanical drives, gears, mechanical drives. Utilize gears to transmit power and motion. They are commonly found in vehicles, machinery, and mechanical systems. Belts and chains. These drives use belts and chains to transfer power and motion. They are commonly employed in conveyor systems and power transmission applications. Hydraulic drives. Hydraulic drives use fluid pressure to generate motion. They are extensively used in heavy machinery, construction equipment, and automotive systems. Components such as pumps, motors, and hydraulic cylinders enable precise control and high force output. Pneumatic drives. Pneumatic drives rely on compressed air to create motion. They are widely used in manufacturing, robotics, and automation systems. Pneumatic cylinders, valves, and air compressors are key components that enable quick response times and simple control. Electric drives. Electric drives convert electrical energy into mechanical motion. They are versatile and efficient, finding applications in various industries. Different types of electric drives include DC drives, AC drives, and servo drives. They power industrial machinery, household appliances, and transportation systems. Applications of drives. Mechanical drives find applications in vehicles, industrial machinery, and mechanical systems where power and motion transmission are required. Hydraulic drives are crucial in heavy machinery, construction equipment, and automotive systems that require high force and precise control. Pneumatic drives are extensively used in manufacturing processes, robotics, and automation systems for quick and reliable motion control. Electric drives power a wide range of applications, from industrial machinery to household appliances, and they are instrumental in transportation systems. Conclusion. Drive systems are vital for powering innovation and automation across various industries. Understanding the different types of drives and their applications enables engineers and professionals to make informed decisions in designing and implementing efficient systems. By harnessing the capabilities of these drive systems, we can continue to drive technological advancements and achieve higher levels of efficiency. Thank you for watching this video on the types of various drives and their applications. Stay tuned for more insightful content, and don't forget to subscribe to our channel for future updates. Together, let's continue to explore and embrace the power of drive systems in shaping our world.
Water Hammer Control Solution. Title: Taming the Water Hammer, Introducing the Ultimate Control Device. Introduction. Welcome back, fellow DIY enthusiasts. Today we have an exciting topic to discuss that will save you from those annoying and potentially damaging water hammer situations. We're going to introduce you to the ultimate water hammer control device that will put an end to those loud bangs and protect your plumbing system. So let's dive right in. Segment 1. What is water hammer? Host. Before we delve into the solution, let's understand the problem. Water hammer occurs when the flow of water in a plumbing system suddenly stops or changes direction, causing a shockwave that reverberates through the pipes. This results in a loud banging noise that can be quite unsettling. Segment 2. The dangers of water hammer. Aside from the annoying noise, water hammer can have severe consequences. It puts excessive stress on your pipes, fittings, and appliances, leading to leaks, bursts, and even system failure. It's crucial to address this issue promptly to avoid costly repairs and potential water damage. Segment 3. Introducing the ultimate water hammer control device. Host. But fear not, folks. We have a fantastic solution for you, the ultimate water hammer control device. This device acts as a shock absorber, reducing the intensity of the shockwave and eliminating those unsettling bangs. Segment 4. How the device works. Host. Let's take a closer look at how this water hammer control device works. It features a specially designed chamber filled with compressed air or gas. As the water flow suddenly stops or changes direction, the shock wave is absorbed by the compressed air, preventing it from reverberating throughout the system. Segment 5. Benefits of using the water hammer control device. Host. Now let's discuss the benefits of incorporating this device into your plumbing system. Firstly, It eliminates water hammer noise completely, providing you with a quiet and peaceful home environment. Secondly, it protects your plumbing system from potential damage, saving you from expensive repairs down the line. Segment 6. Installation and maintenance. Installing the water hammer control device is relatively straightforward. It can be placed at strategic locations within your plumbing system, such as near appliances or where the water main enters your home. Additionally, regular maintenance, such as checking the pressure and ensuring the device is functioning properly, is essential to keep it in optimal condition. So there you have it, folks, the ultimate water hammer control device. Say goodbye to those annoying bangs and protect your plumbing system from potential damage. Don't forget to like this video, subscribe to our channel, and hit the notification bell to stay up to date with our latest DIY tips and tricks. Thanks for watching and happy plumbing. Happy.
Slide 2. Common bolt types. Title: Common bolt types. Hex bolts. Hex bolts, also known as hexagon head bolts or hex cap screws, feature a hexagonal head and a threaded shaft. They are widely used due to their strength and versatility. Hex bolts are commonly used in construction, machinery, automotive, and general engineering applications. Carriage bolts, also called coach bolts, have a smooth, rounded head and a square or ribbed neck beneath it. The square neck prevents the bolt from turning while tightening. These bolts are commonly used in wood-to-metal connections, such as in construction and furniture assembly. Anchor bolts. Anchor bolts are designed to secure objects to concrete or masonry structures. They have an embedded end, often with a hook or a threaded end, and a protruding end with a nut and washer. Anchor bolts are used in construction, structural engineering, and industrial applications where strong and stable connections are required. Slide 3. Specialized bolt types. Title: Specialized bolt types. Eye bolts. Eye bolts have a circular loop or eye at one end and a threaded shaft at the other. They are used for lifting heavy loads or as attachment points for cables, ropes, or chains. Eye bolts are commonly used in construction, rigging, and marine applications. U-bolts. U-bolts have a U-shaped design with threaded ends on both sides. They are primarily used to secure pipes, rods, or other cylindrical objects to flat surfaces. U-bolts find applications in construction, automotive, and plumbing industries. Tension control bolts. Tension control bolts, also known as TC bolts or twist-off bolts, consist of a bolt, washer, and a special nut. They are designed to be tightened to a specific tension using a calibrated wrench. Tension control bolts are commonly used in steel structures, bridges, and seismic-resistant applications. Slide 4. Summary and conclusion. Title: Summary and conclusion bolts are essential fastening devices used in various industries and applications. Common bolt types include hex bolts, carriage bolts, and anchor bolts, each with specific features and applications. Specialized bolt types, such as eye bolts, U-bolts, and tension control bolts, cater to specific requirements. Selecting the appropriate bolt type is crucial for ensuring structural integrity and reliable connections. Understanding the different bolt types and their applications is vital for professionals in engineering, construction, and MA. Title: How does the tendering process work? Introduction. The tendering process is a crucial aspect of procurement for organizations seeking goods, services, or construction projects. It involves a systematic and competitive approach to ensure transparency, fairness, and equal opportunities for all parties involved. In this video, we will walk you through the key steps of the tendering process. Step 1. Identifying the need. The process begins with the organization identifying its requirements and creating a detailed scope of work or specifications. This document outlines the project's specifics, including deliverables, timelines, and technical requirements. Step 2. Publishing the tender. Once the scope of work is established, the organization publishes the tender. This involves issuing a formal invitation to potential suppliers or contractors to submit their bids. The tender is typically made available on the organization's website, trade publications, or e-procurement platforms. Step 3. Pre-qualification. Some organizations include a pre-qualification stage to assess interested parties. During this phase, potential bidders are evaluated based on criteria such as financial stability, relevant experience, or technical expertise. The purpose is to shortlist qualified and capable bidders. Step 4. Bid submission. Interested parties prepare and submit their bids according to the requirements outlined in the tender documents. Bids usually consist of a technical proposal detailing how they will fulfill the project requirements, a commercial proposal specifying pricing details, and any supporting documentation requested. Step 5. Evaluation. The organization forms an evaluation committee to thoroughly review the submitted bids. They assess each bid based on predetermined evaluation criteria, which may include factors such as price, quality, experience, and compliance with the requirements. The evaluation process is conducted objectively and without bias. Step 6. Awarding the contract. Following the evaluation, the organization selects the winning bid. The chosen bidder is notified and the contract is awarded. At this stage, negotiations may take place to finalize the terms and conditions before the formal contract signing. Step 7. Debriefing. To promote continuous improvement, organizations often offer debriefing sessions to unsuccessful bidders. These sessions provide feedback on their bids, helping them understand where they fell short and allowing them to enhance their future submissions. Conclusion. The tendering process is designed to ensure a fair and transparent selection of suppliers or contractors. It enables organizations to acquire the necessary goods, services, or construction projects while offering equal opportunities to interested parties. By following the steps we've discussed, organizations can foster a competitive environment that benefits both the procurers, dam catchment area, and dam effective area. Dams are crucial infrastructure for water management and various applications. Understanding the dam catchment area and dam effective area is essential for effective dam operation. This presentation explores the concepts and significance of these areas. Dam catchment area, the geographical area upstream of a dam that contributes water to the reservoir. Factors influencing the catchment area: topography, land features, and precipitation, rainfall, snowmelt. Catchment area determines the potential inflow of water into the reservoir. Importance: water supply. The catchment area collects and stores water, ensuring a sustainable supply for various purposes. Inflow prediction. Understanding the catchment area helps in estimating water inflow rates and managing water resources effectively. Quality control. Monitoring the catchment area aids in assessing water quality and implementing necessary measures. Dam effective area. Definition: the surface area of water held behind the dam when the reservoir is at its full capacity, determined by the dam's design, capacity, and the elevation at which it is considered full. The effective area represents the storage capacity of the reservoir. Significance: water storage. The effective area determines the volume of water that can be stored for various purposes. Water allocation. It helps in planning water allocation for drinking water supply, irrigation, industrial use, and environmental needs. Hydropower generation. The effective area influences the potential energy generation capacity of a hydroelectric dam. Management considerations: sustainable water management, balancing water supply and demand based on catchment area and effective area. Flood control. The catchment area's contribution helps in predicting and managing potential flood events. Environmental impact. Assessing the impact of dam construction and reservoir on the catchment area's ecosystems. Conclusion: the dam catchment area and dam effective area play crucial roles in water management and dam operations. Understanding these areas aids in sustainable water resource planning, flood control, and hydropower generation. Proper management and monitoring ensure the effective utilization of dam infrastructure. Slide 1. Title: Different types of pipes. Slide 2. Introduction. Pipes are essential components of various industries and applications. This presentation provides an overview of different types of pipes and their characteristics. Slide 3. PVC pipes. Polyvinyl chloride, PVC. Pipes are lightweight, durable, and cost-effective. Widely used in plumbing, irrigation, and drainage systems. Resistant to corrosion, chemicals, and UV radiation. Slide 4.2. HDPE pipes. High-density polyethylene, HDPE. Pipes offer excellent strength and flexibility. Used for water supply, gas distribution, and sewage systems. Resistant to abrasion, chemicals, and impact. Slide 5.3. Copper pipes. Copper pipes are known for their excellent heat and corrosion resistance. Commonly used in plumbing, HVAC systems, and refrigeration. Easy to install and long-lasting. Slide 6. 4. Stainless steel pipes. Stainless steel pipes are highly durable and resistant to corrosion, used in industries such as chemical, oil and gas, and food processing. Suitable for high-pressure and extreme temperature applications. Slide 7.5. Galvanized steel pipes. Galvanized steel pipes are coated with zinc for corrosion protection, commonly used in water supply systems, outdoor applications, and fencing. Affordable and relatively strong. Slide 8.6. PEX pipes. Cross-linked polyethylene, PEX. Pipes offer flexibility and ease of installation, used in plumbing and radiant heating systems, resistant to corrosion and freeze damage. Slide 9.7. Concrete pipes. Concrete pipes are durable and widely used in drainage and sewage systems. Provide strength and stability for underground applications. Available in different sizes and shapes. Slide 10.8. Cast iron pipes. Cast iron pipes are known for their strength and durability, commonly used in sewage and stormwater drainage systems, resistant to fire and noise transmission. Slide 11.9. Ductile iron pipes. Ductile iron pipes offer strength and flexibility, used in water supply systems and wastewater treatment plants, resistant to corrosion and external loads. Slide 12. Conclusion. Understanding the different types of pipes is essential for selecting the appropriate material for specific applications. Consider factors such as durability, corrosion resistance, temperature, and cost when choosing pipes. Consult with professionals to determine the best pipe material for your project. Slide 13. Thank you. Title: Comparison between deep well pumps and submersible pumps. Slide 1. Introduction. Deep well pumps and submersible pumps are two commonly used types of pumps for extracting water from wells and other underground sources. In this presentation, we will explore the key differences between deep well pumps and submersible pumps, highlighting their features, applications, and advantages. Slide 2. Deep well pumps. Deep well pumps are designed to operate from deep wells or boreholes. They are typically installed above the ground, with a vertical shaft extending into the well. Deep well pumps are primarily used for high-volume applications, such as supplying water to large agricultural fields or industrial processes. These pumps are capable of lifting water from considerable depths, often exceeding 100 feet. Slide 3. Submersible pumps. Submersible pumps are designed to be fully submerged in water. They are usually installed at the bottom of the well or other water sources. Submersible pumps are commonly used in residential, commercial, and municipal applications, such as supplying water to homes, buildings, or irrigation systems. These pumps are ideal for shallow wells or water sources with a depth of up to 100 feet. Slide 4. Pumping mechanism. Deep well pumps. Deep well pumps utilize centrifugal force to move water. They typically have an impeller that spins rapidly to create a pressure difference, forcing water to move upward through the pump and eventually out of the discharge pipe. Submersible pumps. Submersible pumps can also use centrifugal force or positive displacement mechanisms. They consist of a motor and pump assembly, which are sealed together in a watertight casing. The motor drives the pump to push water upward, directly from the submerged location to the surface. Slide 5. Installation. Deep well pumps. Deep well pumps are installed above ground, typically in a pump house or a dedicated shelter. The pump is connected to the well through a pipe or conduit, allowing water to be drawn up from the deep source. Submersible pumps. Submersible pumps are installed directly inside the well or water source. The entire pump assembly is submerged, eliminating the need for an above-ground housing or shelter. The pump is connected to the discharge pipe that transports water to the desired location. Slide 6. Maintenance deep well pumps. Deep well pumps are generally easier to access for maintenance and repairs, as they are installed above ground. Routine maintenance may involve inspecting and cleaning the pump components, checking electrical connections, and replacing worn-out parts. Submersible pumps. Submersible pumps require professional assistance for maintenance and repairs since they are submerged in water. Periodic inspections may involve checking the motor, seals, and electrical connections for any signs of damage or wear. Slide 7. Advantages. Deep well pumps, suitable for high-volume applications and deep wells. Easy accessibility for maintenance and repairs. Can handle corrosive or abrasive water conditions. Submersible pumps, efficient and reliable operation due to direct submersion in water. Space-saving installation as no above-ground housing is required. Ideal for shallow wells and residential applications. Slide 8. Conclusion. Deep well pumps and submersible pumps offer different solutions for water extraction based on the specific requirements of the application. Deep well pumps excel in high volume and deep well scenarios, while submersible pumps are more suitable for shallow wells and residential applications. Understanding the differences and advantages of each pump type allows for informed decision-making when choosing the appropriate solution for a given water extraction project. Slide 9. Thank you. Questions and answers. Title: Comparison between concrete volute pumps and metallic volute pumps. Slide 1. Introduction. Concrete volute pumps and metallic volute pumps are two types of pumps commonly used in various applications for fluid transportation. In this presentation, we will compare and contrast the features, construction, and advantages of concrete volute pumps and metallic volute pumps. Slide 2. Concrete volute pumps. Concrete volute pumps are made from a combination of steel reinforcement and cast-in-place concrete. The volute casing, impeller, and discharge elbow are constructed using concrete, providing high strength and durability. These pumps are commonly used in water treatment plants, flood control, irrigation, and large-scale industrial applications. Slide 3. Metallic volute pumps. Metallic volute pumps are typically made from materials such as cast iron, stainless steel, or other metals. The volute casing, impeller, and other components are manufactured using metallic alloys, ensuring robustness and corrosion resistance. Metallic volute pumps find application in commercial buildings, residential water supply systems, firefighting, and general fluid transfer processes. Slide 4. Construction. Concrete volute pumps. The concrete volute pump construction involves forming a spiral-shaped casing using molds, into which concrete is poured and reinforced with steel bars. The impeller is typically made of a metallic material, such as cast iron or stainless steel. The concrete casing provides structural integrity and helps minimize turbulence and hydraulic losses. Metallic volute pumps. Metallic volute pumps consist of a volute casing, impeller, and other components manufactured from metallic materials. The casing and impeller are precision machined or cast from materials such as cast iron, stainless steel, or bronze. Metallic construction ensures resistance to corrosion, erosion, and wear, making these pumps suitable for various fluid types and operating conditions. Slide 5. Advantages of concrete volute pumps. High structural strength and durability due to reinforced concrete construction. Excellent resistance to corrosive and abrasive fluids. Lower manufacturing costs compared to metallic volute pumps. Can be custom designed and constructed for specific applications and flow rates. Slide 6. Advantages of metallic volute pumps. Wide range of material options, allowing for compatibility with different fluid properties. Superior corrosion resistance, especially when dealing with aggressive or chemically active fluids. Precise machining or casting ensures hydraulic efficiency and optimized performance. Easier maintenance and repair due to standardized parts availability. Slide 7. Limitations of concrete volute pumps. More difficult to modify or retrofit due to the permanent nature of the concrete construction. Larger footprint and heavier weight compared to metallic volute pumps. Higher initial installation costs, especially for smaller scale applications. Slide 8. Limitations of metallic volute pumps. Susceptible to corrosion in certain aggressive fluid environments without proper material selection or protective coatings. May require more frequent maintenance and replacement of metallic components due to wear and tear. Higher manufacturing costs, especially for specialized alloys or materials. Title: Comparison between gravity and pressurized systems for water distribution. Slide 1. Introduction. Gravity and pressurized systems are two commonly used methods for water distribution in plumbing and water supply networks. In this presentation, we will compare and contrast gravity systems and pressurized systems, examining their principles, components, and advantages. Slide 2. Gravity system. A gravity system relies on the natural force of gravity to distribute water. It utilizes a higher elevation water source, such as a reservoir or water tower, to create pressure and allow water to flow to lower-lying areas. Gravity systems are commonly used in rural areas, where the topography facilitates the distribution of water by gravity. Slide 3. Pressurized system. A pressurized system uses mechanical devices, such as pumps or pressure tanks, to generate and maintain water pressure. Water is pumped into the distribution network under pressure, allowing it to reach all areas of the system. Pressurized systems are prevalent in urban areas, buildings, and complex water supply networks. Slide 4. Principle of operation. Gravity system. Water flows downhill due to gravitational force, utilizing the potential energy of the higher elevation source. The height difference between the source and the distribution points determines the pressure and flow rate. Pressurized system. Water is pumped into the distribution network, creating pressure that forces water to flow through the pipes. Pressure is maintained by pumps or pressure tanks, ensuring consistent water supply to all areas of the system. Slide 5. Components. Gravity system. Water source, reservoir or water tower at a higher elevation. Gravity pipes or channels to carry the water downward. Distribution points at lower elevations to access the water. Pressurized system. Pumps or pressure tanks to generate and maintain pressure. Pipes and valves to transport and control the flow of water. Distribution points equipped with fixtures, such as faucets and outlets for water usage. Slide 6. Advantages of gravity systems. Reliance on natural forces, reducing energy consumption and operating costs. Simplicity of design and operation, requiring minimal mechanical components. Suitable for areas with favorable topography and sufficient elevation differences. Lower maintenance requirements compared to pressurized systems. Slide 7. Advantages of pressurized systems: flexibility to distribute water to any location regardless of topography. Consistent water pressure throughout the system, ensuring reliable water supply. Ability to serve multi-story buildings and complex plumbing networks. Enhanced control over water pressure and flow rate for various applications. Slide 8. Limitations of gravity systems, dependent on topography and elevation differences, limiting their applicability in certain areas. Lower pressure and flow rates compared to pressurized systems, affecting water delivery in higher or distant locations. Potential challenges in supplying water to elevated areas or multi-story buildings. Slide 9. Limitations of pressurized systems. Higher energy consumption due to the need for pumps or pressure tanks. Increased complexity in design, installation, and maintenance. Susceptibility to pump failures or power outages, leading to disruptions in water supply. Slide 10. Conclusion: gravity systems and pressurized systems offer distinct advantages and considerations for water distribution. Gravity systems are cost-effective, energy-efficient, and suitable for areas with suitable topography. Pressurized systems provide flexibility, consistent pressure, and adaptability to various building types. Title: Sluice valve, controlling flow with precision. Slide 1. Introduction. Welcome to our YouTube video on sluice valves. Learn about the fundamentals and applications of sluice valves. Slide 2. What is a sluice valve? Also known as a gate valve. Controls the flow of fluid in a piping system. Provides full flow with minimal pressure drop when fully open. Ensures tight shutoff when closed. Slide 3. Structure and operation. Consists of a gate or wedge-shaped disc. Disc can be raised or lowered to control flow. Fully open position. Disc lifted completely out of the fluid path. Fully closed position. Disc lowered to create a tight seal. Slide 4. Applications. Water supply systems. Sluice valves control water flow in pipes and mains. Wastewater treatment plants, used to regulate flow and isolate sections. Oil and gas pipelines, essential for controlling fluid flow. Industrial processes, ensure precise control and shutoff. Slide 5. Advantages of sluice valves. Robust construction for durability and longevity. Reliable operation in various environments. Provide full unobstructed flow when fully open. Ensure tight shutoff for leak-proof sealing. Slide 6. Limitations and considerations. Not suitable for flow regulation or throttling. Can cause turbulence and damage if operated partially open. Manual operation with hand wheel or lever can be automated. Regular maintenance and periodic inspections are important. Slide 7. Conclusion. Sluice valves are essential for controlling fluid flow. They provide full flow and tight shutoff. Widely used in water supply, wastewater treatment, and industrial processes. Slide 8. Thank you. We hope you enjoyed this presentation on sluice valves. Stay tuned for more informative videos on engineering topics.